What started as a search for water on Mars, on Earth became ASTERRA. Experts in underground soil moisture and leak detection, we are now saving the world billions of gallons of drinking water annually. And that's just a glimpse of the potential of our technology and our vision for the future. To be better citizens of a more sustainable world. To make that possible, ASTERRA has grown beyond leak detection to provide infrastructure data across industries. Soil moisture for road, rail, and mining. And for earthen dams and levees. Pipe condition assessment for water and wastewater. Ground conditions for infrastructure planning. Unprecedented infrastructure intelligence driving more informed decisions to build the future we envision. A safe, clean, efficient, and sustainable planet for all. ASTERRA, the intelligence to act.
Great, thank you. So, any of you knows what is the overall vision wavelength from the overall gamut? Anyone? So it's 0.03%. What we see is 0.03% from reality, and we think this is reality. There is so much out there. Synthetic aperture radar is 15% of reality. The mission of ASTERRA is to make radar, synthetic aperture radar wavelengths, available for humanity to use. I'll provide some examples, but before that, let's talk about the company. The company is already established. We have $15 million of ARR for different customers. The company is running on a very nice growth rate and gross margin. We have a pipeline of more than $83 million. A lot of it is coming from what is called PNRR in Europe. We are running on flat EBITDA more or less. The company, we would like to raise money, but it's not that we are desperate. And we have 181 customers all around the world on some type of an ongoing service agreement. The technology is based on what is called PULSAR, polarization SAR, which is different than INSAR. Those of you that are coming or understanding a little bit in SAR, what we are doing, we are taking an image, SAR image, breaking it into the different polarization, and our algorithms are running on the different polarizations to get an insight of what we are seeing. We basically use the wavelength that can penetrate the ground, and we can see what is happening under the ground to a certain degree. We run a team that based on geophysicists, data engineers, radar engineers, and software engineers. It's a really interesting group to manage. We are the larger commercial user for the L-band satellites available today in the world. A little bit about the technology. What we do, as I said, we basically take an image, we analyze it, and we provide location of hazardous locations to infrastructure companies. Our customers are basically people that wear helmets, boots, yellow jackets. They wake up in the morning, they take our data, they get into a truck, and they drive somewhere to fix something. We are dealing with real problems where people actually need to go and make things better for everybody. For those of you that are not familiar with the Earth observation market, this is a map that shows our position. The Earth observation market consists of 4 layers. At the bottom, there are those that actually collect the data, the satellite companies. There are plenty of them, and data is becoming more and more of a commodity. Then there are companies that make this data available on the cloud. AWS is very known for it, but there are some that are actually doing it also as a marketplace, cloud-based solution. And then the companies that's supposed to make sense of that data. It has 2 stages, the analytics stage, or the insight stage, and the application stage. And this is where ASTERRA plays. We are playing on both levels, the analytic and the application. I'm going to talk a little bit about the applications. What problems do we solve, and to what industry? On all other areas which are not applications, we are working with some of the other companies here, for example, Planet, Orbital is Insight, and so on, to deliver solutions that they are already addressing a market with their solution, and by using our data, which is based on SAR, they are improving the solution to their customers. So the first application I would like to speak about is what is called non-revenue water. About 20 to 30% of the water that are water utilities, those that bring the water into our houses and businesses, are pumping and treating, simply disappear into the ground through leaks. We're talking about an infrastructure, pipes, that is aging much faster than the ability to renew the pipes. It ends up with broken pipes, leaks, and huge amount of water that is getting disappeared. What ASTERRA is doing, we are identifying those leaks under the ground from space. Yes, we can see leaks under the ground from space. It's based on the ability of synthetic aperture radar to penetrate the ground and come back with information on the material that it hits, in that case, wet ground. In fact, we can actually see the difference between treated water and non-treated water, and we are running different algorithms for water utilities and for sewage utilities. We have already saved huge amount of water all over the world. On an annual basis, we are saving those water utilities a lot of water. We are active in Europe, we are active in the United States, we are active in Latin America, we are active in China and Japan. You may not know, but 20% of the energy produced in the Western world is pushing water, which means that if we are losing water, we are losing energy. So, yes?
Can you detect underground water reservoirs?
Well, let's address that in a second. I'll just say that we are touching the subsurface up to several meters. Okay, so anything that is under the ground for 1 or 2 meters would be fine. If we are talking about the desert, dry area, sandy, we can go even 10 meters, but that's probably for some other applications. So let's go back to the energy saving. As I said, there is a direct relation between water and energy saving, and that's also a measurable item. We are also helping infrastructure companies to better maintain their infrastructure. Those events, those type of events of landslides, help people from using transportation or from their houses into school, hospitals, and so on. Those events are very common in terrain area like Switzerland, Scotland, and other places, potholes, sinkholes. All of those events starts with drainage or changes in drainage in the ground. We can detect it weeks, months, and years before it happens, and we can send the teams to go and fix it before it happens much earlier. So we're talking here about prevention versus reaction. Here is another example of a market that we are addressing. This phenomena that is called tailing dams is a byproduct of the mining industry. We are talking here about sludge that needs to be contained in a dam for years and years after the mining or the mine is not active anymore. In this specific event, the death toll was in the magnitude of hundreds, and the company that was responsible for this mine is still paying billions of dollars in compensation for the people that died over there. We managed to take an image, a SAR image, from an archive, a satellite archive 3 months before the event, and we could show that we could have detected this event way before it actually happened. And based on that, we have developed a technology that is now sold to miners to detect those events before they happen. And now, our technology is also going to exploration. We have developed a machine learning algorithm to detect minerals from space. We are helping exploration companies to better understand where the minerals are. In that case, we are talking about lithium. In the US, lithium would be the only way to allow the electric vehicle revolution. And right now, the US market is totally dependent on the Chinese lithium supply. As you can all understand, that's not sustainable. And here we go. In that case, we're talking about some cases in Nevada and in Utah, where we are helping miners to focus their effort in the areas with higher likelihood of finding lithium. And we do that from 640 kilometers above the ground. Any questions?